Okay. So in question number one, what we are supposed to do is this. So it's a flat tube in which the liquid is flowing. And you can see the radius is varying from the inner circle to the outer circle. And and we have a liquid flow like this. Imagine this is the flow of liquid. So liquid is moving through this tube, and if you just consider a random particle, if you consider a random particle of a liquid, and if you attach a distance from the center as r, so we can say one thing for sure that there must be some net force acting towards the center. Then only the circular path is possible. So for the mathematical analysis, you know how we consider a particle because I want to write the net force towards center. So I'll consider a tiny cylinder around this part, tiny cylinder, in which the pressure will act from the outside as P plus dP. From inside, it's acting this way, P, and okay, so you can imagine like this. So at a distance r and this length of the cylinder is let's say dr. The pressure acting at the cylinder at a distance r is P, and at a distance r plus dr is P plus dP. And if you consider cross sectional area as dA, it's very easy to write the net force towards the center. So what is the net force towards the center? We have done this in the fluid mechanics. The net force towards center equals to P plus dP into dA minus PdA, right? And this will be equals to dP into dA. Now, how to write the mv square? So, if the velocity of the particle, if we consider as v, so this must be equals to dm v square bar. So, therefore, dP into dA, and then the mass connect as density into volume of cylinder, which is dA dr. So we can see that the dA gets cancelled out. dP we get a formula as rho v square by r into. So this is the equation of pressure versus radius relation. Okay, like this. Now the question is how to apply the Bernoulli equation. Okay. So if you go R to R plus dr, the velocity will change because the pressure must change. So to write the Bernoulli equation, what you can write is P plus half rho V square plus the third term, which is 0, I will take. Why? Because there is no vertical motion, it's in a flat surface, so it's a horizontal motion. So the level of the liquid is fixed, it's not changing. Or if you want to write as rho G H, and H is constant. So this third term is anyway constant, so this is a constant. So you can switch to the other side, and what you left with is so now if you differentiate dp plus half rho 2v dv. So this is the equation from the Bernoulli curve, and this is basically the Euler's equation, if you remember. So if you combine the pressure relation of the Euler's with laws of motion from 1 and 2, you can substitute dp as rho v square by r dr plus rho v dv. And if I divide by the v square both sides, I mean, sorry, not both, yeah. So what we get is rho dr by r plus dv by v, right? Equals to 0. And the rho is a multiplier, so it will be also 0. So eventually what we get is dr by r plus dv by v equals to 0. And if you integrate now both sides, it becomes ln r ln v equals to constant. So I write in next equals. So integrating what you get, ln r plus ln v is constant, which means ln vr is constant. This implies v into r is constant, which means so graph between the v versus r will be hyperbola, rectangular sorry, hyperbola. So as r will increase, velocity will decrease. So it's a maximum near the nearest smaller radii. Okay, it's a challenging problem, like not so easy to think for the first time, but this is how you can attempt. Okay,
Yes, sir.
any doubt in this?
No, sir.
Sorry, guys. Our today's topic is SHM, which stands for simple harmonic motion. And what you need to remember that this is one of the most crucial chapter in physics because this is the foundation of all types of complex oscillation, which you may study in the graduation or masters. So vibration is a law of nature. Like everything which you think of in the nature is already in vibration, and the vibration begins at atomic level. So even if you think of the H2 molecule, so you may think as two tiny masses attached to a spring. And so effectively when a H2 molecule acts as a spring mass system and at a different temperature range, it starts vibrating. And this leads to the phenomena of vibrational kinetic energy, if you know. At low temperature, the effective spring constant is very high, and therefore it acts as a rigid rod instead of like a spring. So the vibration is generally a high temperature phenomena. At low temperature, the molecules behave as a rigid body or rigid object, and they do not unlock their sorry, and they do not unlock their vibrational oscillation, and therefore they do not unlock their vibrational energy, and they stick with mostly the translational and rotational energies, but not the vibrational. So So vibration is the part of nature. So if a molecule is vibrating all the time, so imagine anything made of molecules. So even a building, the human body, or you can say table, chair, everything is made of some molecule, and these all molecules are under vibration all the time. So there is nothing in this universe which is without vibration, and these vibrations are very powerful. And if you can match this vibration from external agent or source, they will break down into pieces. So you may break a glass using the some ultrasonic sounds. You might have seen movies that they move a ring and they break the glass in like James Bond movies. So that ring which he wears will have the ultrasonic sound creator, you can say. And by virtue of this ultrasonic sound, which are very high frequency sound, and a general frequency of if the frequency of the you can talk about the stationary object, it's very high. So the glass building materials, these are oscillating at very high frequency. Matching that frequency on a regular basis is next to impossible. But if you can match somehow, you can shatter into pieces those things. So why this happens? There is a phenomenon called resonance. We'll come to know about this resonance at the end of this chapter. So the birth of SHM is inherent to the birth of universe, and when we see the complex motion or complex oscillation like seismic wave, earthquake, if we go on analyzing this seismic wave at a very small scale, it ends up becoming SHM also. So this was first of all analyzed by James Fourier, and what he analyzed that even a complex wave, which is not like a sinusoidal wave, maybe I can create a wave like this with oscillation, which is very random. You can see this. So what James Fourier said that any complex vibration in nature is basically a superposition of infinite SHM. It means if you keep on superimposing various SHM of a different frequency, so it will turn out to be a very complex oscillation. So if you break down into a simpler one, what you will get is the SHM one. So any complex vibration in nature is basically composed of multiple SHM of varying frequency. So of course each SHM will have different frequency, and when you superimpose, this will happen. Now this Fourier transform is a very powerful method nowadays. I mean, for the NLP processing, for the neural language processing, on which we have the devices like the Alexa or the Siri or something else, Google. Uh, what is Google? Uh,
Google Home.
Google Home. No, but there is a name for it. It's not Google Home. Like Alexa is a name, Siri is a name, uh, Cortana is a name for Microsoft, and there's something for Google. Okay, something like that. Okay. So what they do is when the voice signal of every human being is again collection of infinite SHM, and these fast Fourier transform and Fourier transforms are method which can break down any complex signal as a summation of like infinite number of SHM, or basically we call sinusoidal signals, and they are able to reconstruct the same voice, and they are also able to understand the same voice because they can pick the frequency. So every person will say something will have some pattern in its the way he says, and these patterns are not common for humans, but for machines these are very common things, and they can easily distinguish between the two separate patterns which human brain cannot do. So by analyzing the pattern of the different voice signals, they understand who, I mean, who is the person who's talking to, and there are many other, I mean, applications, of course. So all the language processing takes place using the Fourier transform, and Fourier transform is the basis of, or you can say, the system is the basis of any Fourier transform. So that's why this chapter is very important. Going into future, we need to understand even more complex behavior of this chapter. So I will try to give you some glimpse into the world of application of systems. Eventually, our nature, like what we are learning all this chapter, the eventual reason is the understanding wave and interpret in communication. Because at the end of everything which you learn, what you try to do is you communicate. So you communicate with each other. So you have the telephone, Wi-Fi, you have the various FaceTime, WhatsApp, uh, chatting features. Like everyone will have the voice features. So every app which is trying to develop the voice features, they end up applying this concept of Fourier transform. And for that, there are many libraries already in place in various languages which they use directly. And these are developed by the mathematicians. Okay. So what SHM stands for is simple harmonic motion, but it is the most complex term. Simple is the most difficult term to understand. So we'll try to understand what exactly is SHM, and for that we'll first start with the right hand side, and we will try to go towards the. So if we start with the right hand side, the name is motion, and I hope you all are aware of motion, right? So I will not explain what is motion, but I'll go to the next part. So there is something called periodic motion. So what is periodic motion? Any
Which
motion
repeats itself.
after fixed time interval, right? Any motion which repeats after fixed time interval. Now tell me if a motion is repeating after fixed time interval, then we call it periodic motion. Now, is it necessary that if a motion is periodic, it must be oscillatory?
So can you repeat?
Can we say that every periodic motion must be oscillatory motion? Is it necessary that if you have a periodic motion, then you must be oscillatory as well? Yes or no? Is it necessary that every SHM must be oscillatory? Yes or no? Tell me.
So every periodic does not have to be oscillatory.
Right. Exactly. So if you talk about the motion of planets around the sun, these all are periodic motion, but they're not oscillatory. So what is oscillatory motion? So we say that when a particle moves to and fro with respect to a fixed point is called oscillatory motion, right? Now tell me, is it necessary that if a motion is oscillatory, it must be periodic? Yes,
Yes,
please.
sir.
Yes.
No, there's no correlation like this. So let's say if I'm like uh, driving a car by taking a reverse gear and forward gear. So I'm moving forward at a high speed but backward at low speed. Then after a while, I start moving backward with high speed and forward with low speed. So am I maintaining the time period of one oscillation? Is it always same?
No.
Not. So just
So I
because
didn't
my motion
understand the
is
example.
oscillatory, pardon?
So I didn't understood the example.
See, it's like this is a fixed point. On let's say this is a marker on a road, and you're driving car to and fro. So you are going ahead, coming back, coming ahead like this. You're repeating this process. So is it necessary that this process will take same time?
No, sir.
It depends on speed. I can change it, isn't it?
Yes,
So
sir.
let's say we have a swing, and there is a wind moving this way. So when the swing will oscillate towards the right, it will go. bit faster, but while coming back, it will slow down because of the air resistance will oppose. So it may have a different time period of oscillation depending on the air resistance and other factors. So we cannot say that just because the motion is oscillating, it must be periodic. So we cannot say like that. So periodicity and oscillatory are two events and they don't have any correlation.
Sure, but in the examples, in every example, we're introducing a external force.
Yeah. So that is called, I mean, what you're saying is called the natural vibration, and there is something called the forced vibration or damped vibration. So when we have a damped vibration, then the time period may vary quite possible. Understood? So
Yes.
the whole idea is you cannot say that oscillatory motion must be periodic. That's the only idea. And this is what you need to realize that just because something is oscillated to and fro, it will not guarantee that it's periodic motion. So the question is, what happens if oscillatory motion becomes periodic motion? Then it's called a different. It is called by a different name, and that is what we call harmonic motion. An oscillatory motion which is periodic as well is called harmonic motion. So now you realize what is the harmonic motion. So we have deciphered the meaning of the last two terms, last two word of this SHM. And the only thing now we need to understand is simple, which is the most difficult part of the chapter. So once you realize what is simple, the chapter is over. So what do we mean by simple? Anyone who can explain? See, I have explained what is periodic motion, what is oscillating, what is harmonic motion, and they were related to each other in one way or the other. But still, the word, the simple is still like mysterious in this naming convention. So, what is the mystery? Mystery is all about. What is simple? How to interpret the word simple in this chapter? Any idea? Anyone?
We are taking a small part of the wave,
Pardon? You're getting a small part of?
the oscillation wave.
No. Okay. So,
Sir,
in the
repetitive,
simple, yes. Tell me. Yeah. Go ahead.
sir, repetitive pattern.
No. So, harmonic motion itself is repetitive. So, is it simple?
So simple because it's very basic. Like,
So, what do you mean by very basic?
So I will taking a dx part of the complex.
What is the dx part? And how taking a dx part will make it simple?
so I basic like I meant it's very like pure motion. Matlab, there's no it's fundamental motion of the particle.
Okay, whatever you are saying is not making much sense to the question, but still, well done for your effort. So that's why I said the simple is the most complex term in this chapter. And no one is tending to understand the word simple. They tend to solve question and learn, read this chapter, they read some books. And I don't know how it is being taught across the world. But let me tell you what is simple. The word simple has come from the mathematics. And in maths, the simple refers to the simplest equation. And the simplest equation is nothing but the linear equation. And what is the linear equation having physical meaning in physics? So when we say linear equation, we that y equals to mx plus c, then what does it represent? What is the physical significance of this linear equation?
Straight
Any
line.
idea? That's not a physical interpretation, that's a graphical interpretation. So in the real world, what these linear equations are doing? Okay, no idea. So I have explained this in the chapter of mathematical tools. Unfortunately, you don't remember anything. So every linear equation represents a proportional variation of two variables y and x. Proportional variation of two variables x and y. What C is doing here? C is called offset. So C is something like I want to start from some value instead of starting from zero. So when you try to start from something new other than zero, we call it offset. So adding a constant will not affect the proportionality. It is still proportional with some offset. So that is the physical meaning of a linear equation. So let's say if you go to buy a grocery from D-Mart, let's say you buy your favorite chocolate or biscuit. So the very first year you enter the market, you were a small kid and you bought one of your favorite chocolate, let's say 5 star, and the price was let's say 5 rupees for the bigger size. Then you kept on going there. Next year the price were become 6 rupees, then 7, then 8. So we can see that the amount of increment of the money every year is just 1 rupees. So we can say there is a linear or proportional increment of the price, but there is an offset price. So the very first day you enter the D-Mart, the price was 5 rupees. So 5 is the like offset value you started with. It is not like that you went to the D-Mart for the first day, everything was at 0 rupees. So you won't get anything for 0 rupees for sure, unless there's some free offer by some sponsor. So C is the initial offset. Like when you go on or even day zero, you have to pay some price. That's will offset. So what we are trying to understand is that whenever there is a proportional variation of two variables, then it is called simple. Now the big question is, what is x and what is y? In our case, in simple harmonic motion. So when we are going to call the harmonic motion as simple, so which two variable must have the proportional relation? Tell me. No idea.
The time period and amplitude.
No.
Frequency wavelength.
Okay. So don't try to apply now much effort. Let me take that. So any harmonic motion in which the acceleration of the oscillating body is proportional to its displacement from the mean position or equilibrium position. So let's say if we have a particle which is oscillating about some random location, let's call it mean position. And if you're moving to and fro from here to here, This is the maximum distance you can go away on either side. And if you are at some random location which is at a distance x from the let's say from mean position, not from anybody else, so the x must be calculated from the mean position. And if you are here, then the acceleration of this particle at this instant must be towards the center, towards the mean, and proportional to the displacement with respect to mean position. And minus means it is opposite to the displacement. So if you're going towards the right, it must be left. Then only it can be SHM. It means the acceleration is always trying to bring you back to the mean position. That's the role of acceleration. So if a particle is oscillating in which we have this proportional behavior, then only we can say it is simple. Otherwise, we cannot say simple. So that's the whole idea of simple. So simple harmonic motion is a mathematical condition about harmonic motion. And that's why it's purely mathematics. It's nothing to do with the physics. So what is SHM now? Any harmonic motion. So first, harmonic motion is a must criteria in which acceleration of oscillating particle is directly proportional to displacement with respect to mean position, like where you were at stationary or at rest. So displacement with respect to mean position or the equilibrium mean means equilibrium position where net force is zero. So I have discussed this in work energy power also, if you don't know. And is always directed opposite to displacement. So when A is proportional to minus x, it's a mathematical condition. So if you equate with, I mean, if you remove the proportional sign with equal sign, we have to put some constant. And I'll put a constant by a name omega square just for the sake of writing. So this is exactly the system. So we'll come to this again, back to this again later on. So let's define some terminology used in this chapter. So what is mean position? So it is a position of particle at which the net force and net torque is zero. It is the position of particle oblique body at which net force, net torque. So if we have a body, we think of torque. If we have a particle, we think of force is zero. So how to get the mean position? So first you go at some random location, draw the ABD and equate the all force to zero, you will get the answer. So the mathematical condition is simple. To find the mean position, we have to use the force equation. So summation of all forces will be 0. That's it. Okay. So generally you will get the one dimension SHM. So you have to write in values. In Olympiad, you may get some two-dimensional problem. You have to express the force in vector notation and then add up to 0. Okay. So that's the definition of mean position. In every oscillation, you go up to certain extent away from the mean. So there's something called extreme position. So how to identify the extreme position? So when you reach the extreme position, can you go beyond that? Yes or no?
No, sir.
So what exactly happens at extreme position? Your velocity becomes 0, instantaneous velocity becomes 0, right?
Yes, sir.
So extreme position is a position at which the instantaneous velocity becomes 0. That's the definition. So maybe the mean is here. You may start from here with u, but it is not necessary that. So your other extreme may be on the left side. This is the extreme. This may be the extreme. When you will come here, again the velocity will be 0. So extreme position means the position where you will turn back, and because you are going to turn back, so you must come to rest. So the simple idea is it is position at which instantaneous velocity becomes 0. Now you cannot say the force is 0. The only thing you can say is the instantaneous velocity is 0, and because the instantaneous velocity is 0, so how we can calculate this position? What is the method to get this extreme value? So to calculate XC, we apply work energy theorem or conservation of mechanical energy. So generally, if there is an external force acting, then we apply the work energy theorem. If there is no force acting, if all forces are conservative, and I'm damn sure that you guys have forgot these definitions. So go back to the work in power and just revise. Everything is explained there. In fact, this chapter I have explained a bit more there only. I don't think you remember it. So to calculate the extreme position, we apply the work energy theorem. And how we apply? So the way to apply, which the way I do is simple. I choose 2 points of the journey at which velocity is 0. So select 2 points in a way, let's say like this. To select 2 points at which velocity is known to you. So for example, I know this is the velocity, the initial given to us. And if this is the extreme portion, then this must be 0. So in fact, because of the nature of extreme portion, we also know this answer. The rule is if you know the two answers, then apply the work energy theorem between these two. So you will apply work done by all force equals to
Half mu square.
change in kinetic energy, and because the final is 0, so it will become 0 minus the k initial, which may or may not be 0. I don't know. So this is the answer which you have to apply, because eventually we apply between the extreme and the something known, and extreme it is going to be 0 for sure. At the beginning I don't know what is going to happen, so that may or may not be 0, so I have just left like this. So these are two basic rules to solve numericals or problems. So to start with, you have to start with the mean position calculation, and this is simple. So the laws of motion will give you mean position, because mean is also called equilibrium position. So equilibrium doesn't mean that it must be at rest there. It means the net force at that instant must be 0. So when you pass through the mean position, at that instant you do not experience any force. At that instant you do not experience any acceleration. So the third definition or terminology used in this chapter is called amplitude. So amplitude is a scalar quantity. It only shows the how far you can go on either side of mean value. So by definition, amplitude is simply the maximum magnitude of displacement with respect to mean position, not any other position. If you want to put into literature, you can write it is defined as maximum magnitude of displacement, because it's a scalar, it's just a value. It is defined as the maximum magnitude of displacement with respect to mean position. That's simple. Like how far you can go from mean, and that's why that mathematically you don't calculate a directly. What you do is you first calculate the extreme mean, calculate the extreme, take the difference, and take their modulus. That's it. Okay. Now the amplitude may be maybe something called angular amplitude. We'll talk about that later on, but just remember the basic. Is this clear, guys? What is mean? What is extreme? What is amplitude? Clear?
Yes.
Okay. Now, since we are talking about the harmonic motion, so time period is a constant quantity. Therefore, the frequency will be also constant, isn't it?
So can you show your previous?
Just
Sir, can you explain how to calculate the amplitude of it?
take the difference of extreme and mean. That's it. X is the coordinate. X is the coordinate of the extreme motion. So from with respect to some random origin, the extreme position is found to be at a coordinate xe. The mean is found to be at a coordinate xm. Then take the difference. That's the amplitude. That's it. Understood? So okay, you can think this way. So let's say there is a oscillation here. So I take the origin here. This is my x mean. This is my x extreme. You can see very far. So my amplitude will be on this much. No? This is so A is extreme minus mean position value, and then take the modulus, because I don't know, it can be on the other side also. So it cannot be negative. It must be positive. Is this clear?
Yes.
So there are confusing elements. Like see, when I use the x here, then this x is the displacement from the mean position. So for example, let's say if I call this as x-axis, if I call this origin, then I cannot take this as x. Now this is a wrong definition. So what I'll do here? So the x coordinate is calculated from here now. This is x coordinate. But what we are looking for is only this value. So you can change the name. You can, let's call it y. and then you can do the change here also. So do not get confused. So coordinate versus displacement from the mean are two different things. So x does not mean x all the time. So I think I have confused you guys by writing like this. So let's remove this. So in mathematical condition of SHM, what we realize that the acceleration is proportional to the displacement calculated from the mean position, not from some other position. Let's call it to O dash or something like this, just to distinguish between the other coordinate system. Okay. And here when I'm writing x mean or x extreme, what I'm writing is I'm writing the coordinate from the origin. I am not writing from the mean or something else, just from a mathematical origin. So once I know that from the mathematical origin you go up to xe value and your mean is at xm value, then your amplitude must be the difference of the two. Is this clear?
Yes.
So the displacement from the mean position is a different than the coordinate. So these are coordinates. These are coordinates, not the displacement. Do you realize this?
Yes.
No.
So if you want to write in vector form, that's better. This is the better representation in vector form. So A is equals to minus omega square delta, and the delta R is the displacement with respect to mean position. So if you want to write in vector form also, so let let me show you in vector form how to write in two dimensions. So let's say a particle is at rest at this position, and the coordinate is given by the position vector r naught. So let's say this is the mean position in two dimensional space or in three dimensions. Doesn't matter. Now you move this particle in some random direction. So this is how much you displace. And the new position vector of this new location is r. If the acceleration developed is in this direction and is proportional to this displacement, we can say it's a simple harmonic motion. So we can write A proportional to minus delta A or you can also write this as omega square r minus r. So in one dimension, when you solve problem in one dimension, in which we have motion along one particular axis, let's say x-axis. Let's say this is something called mean position. So xm is the coordinate of the mean position with respect to origin. This is the extreme position, the coordinate. And if you happen to be here, which is having coordinate x comma 0, so now What we are interested is in this displacement, and this is how much? X minus x mean, right? Do you realize this? So here the acceleration should be proportional to minus of x minus x mean. Understood? So instead of writing like this, what we prefer is by giving a new name to this. Let's call this as z or any other name. Understood? So a becomes minus omega square. So you can think in two dimension also, and this is exactly how we write in two dimension the condition of resistance, because you will come across mostly question of one dimension. So this is the way to write. Is this clear?
Yes.
And now you know the amplitude definition. So the coordinate of the extreme portion is xe comma 0, and the coordinate of the mean portion is xm0. So if I take the difference of these two, then what I get is called amplitude. Okay. So even in two dimension, if I move you, displace you one way, then the oscillation will keep on happening along this direction all the time. So you will move like this, and therefore again you will have the amplitude. So maybe this is the extreme position with a position vector of r extreme. Let's re. So we can say that amplitude is equals to the mod of, I hope you know the mod, re minus r naught. So you know how to use the vector mod, mod one. So you need to write a square b square minus 2ab cos theta, right? So all those things you know. So this way of writing is more meaningful. So you have to write first a difference of vector, and then you take a modulus. In one dimension, it is simply the subtraction. The algebraic subtraction will give you the answer. In two dimension, you have to take, or three dimension, you take the modulus. That's why I prefer to define it as a modulus. Is this clear? Yes or no?
Yes.
So now, do you realize what is the meaning of simple? So what exactly is simple in the simple harmonic motion? Tell me, guys, what is simple? It is a mathematical condition. So for SHM, see, oscillation is a phenomena. SHM is a condition. That is what you need to realize. So every oscillation or every harmonic motion cannot be SHM. Do you realize this? Anybody? We cannot say all oscillation in this universe as SHM. We cannot say every harmonic motion also as SHM. We cannot. Why? The simple answer is it is a mathematical condition, and only those who fulfills this mathematical condition are called performing SHM. So one should not be confused with the word harmonic motion and simple harmonic motion. These two are quite different terms. So every SHM is HM. Every SHM is oscillatory, but vice versa is not true. Is this clear? Yes or no?
Yes.
You can just mention a note. All SHM are oscillatory, but vice versa is not. Is this clear? Hmm?
Yes.
All right. So the other definitions are very famous, like angular frequency. We write omega, and how we define omega? Omega is defined as 12 pi and the linear frequency. So if you make to and flow motion about a mean, so it will take some time to complete one oscillation. So if you begin from the mean, you have to come to the mean. Then this makes one oscillation. But on a circular scale, if you convert this into circular scale, okay, we'll come to that. So just remember the formula that omega, the angular frequency is defined as 2 pi linear frequency. What is F defined as? Frequency inverse of time period. Okay. So these are the definitions that you need to remember. So you should also remember what is wavelength, although not required in this chapter, but just so wavelength is. Oh, but this is not related here, so let's remove this. We're not solving wavelength sound. So I think with these definitions and terminology, we can solve any problem of this chapter. And do remember the vector notation, how to write the SHM condition in vector notation. The omega is the constant term, and the relation between the omega and time period is very much obvious. So omega is 2 pi frequency, but frequency is 1 by t. So omega is 2 pi by t, or time period. So time period we also write as 2 pi by omega, and that's simple. Okay. So let me give you the mathematical derivation of SHM. So when a particle is performing SHM, and is moving between the two extremes, so minus A to plus A, and so let's say I want to know because someone is performing SHM, so it is oscillating between the plus and minus A. So I am really interested in knowing that to reach at a particular position X, how much time it will take, or if at t equals to t, you are here, and let's say you were here at t equals to 0, let's call it x0. Then how much time it would take to reach a particular position x, knowing that you start from the x naught and you start moving this way. So now I'm interested in knowing all the relation between the time, displacement, velocity, displacement, velocity, time, acceleration, displacement, and so on. So now these are my interests. Like I want to know all these things. And the answer is very easy to derive because we know that SHM is a mathematical condition. And what is that condition? A equals to A
Minus
proportional to
method square.
minus X. That's the condition. So because A is proportional to minus X, so it must be equals to some constant. So later on you come to know why I'm choosing this particular value and not just some random name. Because this will simplify the mathematics and it will have some application also. So now accession is a function of X. This is the question of kinematics. And I believe that you know kinematics.
We deliver.
So if I believe this, that you know kinematics, so take take what at uh, x equals to 0, v equals to v naught. Just assume this because you want to integrate, so you need to know some value, right? So if I say that at x equals to 0, sorry, the best way is what we know. So take at x equals to a, v equals to 0. That's better enough because we know that at extreme position velocity is 0, correct?
Yes.
Yes.
So because at extreme position velocity is 0, so this is a good limit value to solve. So when x equals to x, we can take v equals to v. So I am
Yes,
now
yes.
giving the upper and lower limit that you are going to use for solving this problem. And then this is the question of kinematics. Don't think of a system at all. Just forget about the system. Think that if I give you a problem in which if a is equals to minus omega square x, can you solve for v as a function of x?
Yes, sir.
Yes, sir. That's pretty easy. Do it. Go ahead and tell me that. Solve it and let me know.
Sir, initially we had a x is equal to
Yeah, so you take initially not x equals to a. If x is equals to a, whenever x is a v is 0, so that's like a limit. You know the answer. And the upper limit you can take as a random values like x and v, and then solve it. Is this okay?
Sir, I got
Pardon?
sir, I got answer.
Oh, you got the answer. Tell me what is velocity?
V equals omega under root e square minus x square.
Very good. That's correct answer. So now the whole idea is what we have done in the kinematics is what we're going to use here. So physics is over. The SHM is over. The rest is mathematics. So because you know v as a function of x, can you find the x as a function of time t? Because v we can write as dx by dt, right? Isn't it? So can we write v equals to
Yes,
dx by
sir.
dt? So now you know what to do next. Can you use this formula? And you know v as a function of x. After rearranging term, can you get what? X as a function of time t. And this is not difficult. I know this can be solved. Hmm? Everyone, please do the manipulation. So now I'm not going to teach all these things because I have taught all these things in a great detail in kinematics. So everything which I need, you have to solve. If you don't solve, just leave it. Go home, take a rest. I will not teach anything because that's not my job. If you don't derive the kinematical relation, then probably you're not learning anything, and you should stop learning and go back home, do some other household course, leave preparing for JE. Do the integration, everyone. I hope you all have learned the mathematics and you know the basic integration. If you need help in integration, let me know.
So time is 0 to till, right? Limit.
Yeah, take time from 0 to t only. So at 0, do you know velocity? No, you don't know velocity. So what you can do? Assume v naught as velocity at 0. That's it.
Yes.
Or the best way is like, yeah. So you can just assume, let's say velocity at t equals to 0 is v0 because you don't know the answer. So assume it if you need it. Do you need this? No,
Oh, no, sir. No.
you don't know, need this. So
Sir, and the x limit, we have to take x naught to x, right?
yeah. So you have to take x not to x.
So the answer is, sir, 1 minute, simplifying.
Hmm. So you can see the diagram. You can understand from there that I have taken the x not as the initial, and I'm taking the mean as origin. So that's easy for me to take the coordinate as the displacement. So that's an interesting way of doing the problem. So if you choose the mean itself as origin, then the coordinate which you calculate will become the displacement from mean, isn't it?
Should I have got this? It's hello.
Yeah, tell me.
2 by t,
2 by a,
2 by t.
2 by t. Okay.
Sir, do we have to find time? Sorry, 2 by omega into
Hmm.
bracket root under a square minus x square minus root under a square minus x naught square.
No, this is wrong. So it means you don't know the integration. So in mathematics, you have not studied integration, right? The integration is not covered so far.
No,
No,
sir.
Very good. Good excuse. It means you don't know how to solve. So the way to solve is very easy. You have to add dx by dt omega. Bring all the x term one side. So dx upon a square minus x square is omega dt. And simply integrate. This is very famous 0 to t. So what is the integration of dx upon a square minus x square? And if you don't know the answer, then you can do it by the method of substitution. And it's a very famous method of substitution. So dx upon it's in under root. So let me do this part separately. So let x equals to a sine theta. So dx becomes a cos theta d theta. That's easy. And see, we can write as dx as a cos theta d theta upon a square minus a square sine square theta under root. And this is exactly, what is this? A cos theta. It's a pretty simple d theta integration, which is theta. So we know the answer theta. But what we have is x equals to a sin theta. So sin theta is x by a. So theta is sin inverse x by a. So this is the famous answer. So this integration is basically equals to sin inverse x by a. So just mark up this for answer. Okay. If you don't remember, at least remember this way. So now I will not write anything on this page. I'll go to the next page. So what we can write is the integration of dx upon a square minus x square from x naught to x is omega dt from 0 to t. This is sin inverse x by a. That's it. So we can write as sin inverse, and you can understand inverse is the angle value. So sin inverse this angle. So this is the dimension of angle. This is angle. These are angles. So the instantaneous angle minus initial angle is omega t. So generally what we do is the initial angle, or also called the initial phase angle, it's called initial phase angle, or later on we come to know this is also called epoch, or some, it's a French name, difficult to pronounce, German name, I don't know which name. So this is called initial phase angle or epoch, or in most of the literature people just call initial phase. So they don't use the word angle because that's like understood. And for this we have a nice symbol phi. So that's why going by the convention of notation, we can rewrite this equation 1 as the instantaneous angle minus initial angle is the angle omega t. So this you can write as omega t plus phi. Xy becomes sine, because it's the inverse of, see, if this will go this side, it becomes sine omega t plus phi. So x becomes a sine omega t plus phi. So now you know that how this formula came into picture. It's a basic derivation from the kinematics with a little bit of notational changes. And now you know what is phi exactly. So phi is the initial position upon a. So if you start from the origin, if x naught is 0, the phi also becomes 0. Therefore, the answer simply becomes x sine a omega t. So the phi will actually give you the idea about where you started. So you may start from the origin, you may start from the extreme position, you may start from the in between origin and extreme. So that's up to you. But the whole idea is the phi is the indicator that where you begin your journey while you are doing the oscillation. But better, more than that, what you can say that what phi represents is like when you as an observer is started observing the oscillation where you saw the particle in the very beginning. That's called phi. So let's say you are going for a dance performance, a classical dance performance in a some theater. Uh, it's a live performance. So there is a curtain. So once they raise the curtain, you see the dancer in certain pose. Okay, you can call that pose as the initial pose, and then the music starts and the dancer starts dancing. So if someone will enter the theater at a later, I mean, time, maybe after 5 minutes of the starting time, you may see the dancer in a different pose in different location of the stage. So that's called the instantaneous phase, which we represent by the symbol theta. So phi is where you see. So now for the new observer, though the one who entered after 5 minutes, for that observer, your initial position has changed. It's x naught now. So let's say it was actually x0. It was origin in the very beginning, but when you entered, you saw at x naught. So for you, the the phi will be depending on where you saw the performer on the stage. So it depends on who is observing and where that observer observes the particle at t equals to 0, and that's how we relate the phi. So phi is called the initial phase. Initial phase is the angular mapping of linear motion. We'll come to that, called the relation between the SHM and circular motion very soon. And phi actually represent that where you were while oscillating on the x-axis or y-axis. So you can see that what you call phi symbolically represents this value, and this is very important to remember. Is this clear? So only when you start from the origin, then x will take a formula like this.
So
So have
please
you guys
read the page number 8.
studied the probability theory in maths? No. Yes, tell me.
So page number 8. Done, sir.
Okay. So any doubts so far, guys? Tell me. So now I hope you have realized that the formula which you see in books, these are derived from the definition of SHM. And what was the definition? Accretion is proportional to negative of displacement from the mean position, not from anywhere else. Mean position. Is this clear?
Yes, sir.
No. So SHM is pretty simple in terms of derivation. So let me summarize all the formula that we have. A equals to minus omega square x. V we got as omega under root of a square minus x square. And finally we got x equals to a sine omega t plus phi. And phi is sine inverse x naught by a. So this is the mathematical journey so far that we have taken, isn't it? Just look at these formulas. Now, once you get the x value, you can go back and derive formulas in a reverse order. If I differentiate x, what will I get? I will get velocity. And if you do so, what will get the answer? A omega cos omega t plus phi. So once you know the velocity as a function of time, we can differentiate dp by dt. But this is called acceleration. This is again a omega square sine omega t plus phi. You can say acceleration is how much? Minus omega square a sine omega t plus phi. But what is a sine omega t plus phi? X. It's the same thing. Like you can rederive the formula from one to other. Okay. So knowing one formula can lead you to the other formula and vice versa also. But the first method that we took was a difficult method. But now you can see if I know the x value, then going back to the other values are very easy, right? So are these formulas clear to you guys? How to write?
Yes.
Any doubt in this? Tell me.
No, sir.
No. Okay. Fine. Good. So let's say if you're performing SHM, and let's say I take the mean as over here, just to make the things clear. This is x naught, or maybe I can call the t equals to 0. This is a by 2, maybe. If I ask you a simple question, how much time it will take for you to go from here to here? If I say this is t equals to 0, how much is this t? Who can answer this question? So if you start from the origin, then the formula for x will be how much? Only a sine omega t. Phi will not come, right? If you remember. So if someone is starting from here, I can write x equals to this formula because phi becomes 0. If you realize in the last page, I have derived somewhere. Hmm? It is clear.
Yes, sir.
Yeah.
And if I give you x value, can you find t? That's easy enough. So if x is a by 2, it's easy to solve. So sine of omega t is 1 by 2, which we can write as sine of pi by 6, because sine 30 is half. And if you compare, we get omega t equals to pi by 6. Generally, there is a tradition to write the answer in terms of time period. So we can write omega is 2 pi by t. So t turns out to how much? T by 12. That's easy. So you will only take t by 12 to reach from here to here. And we all know how much time you will take to go from here to here in terms of time period. T by T by what is one oscillation? You go from mean to extreme, you come back, you go on the other direction, you come back, then that's called one oscillation. And this 4 step is capital T. So each step is T by 4. Do you realize this? So distance between the mean and extreme is same on both sides. So the time taken is always 1/4 of the total time period. But to go from 0 to a by 2, the time taken is t by 12. So how much time will you take to go from a by 2 to a? So time taken to go from a by 2 to a will be how much, guys? Anybody?
So 2t by 2.
Hmm?
T by
Hmm?
6.
T by 6. Now, why I'm saying this answer? Because these are the answers which you are supposed to just mug up. So 0 to a by 2, it is t by 12, and a by 2 to a is t by 6. So if you want to go from O2 minus a by 2, it is again t by 12. So I'll give you some simple trick to derive this answer, but as of now, just remember this way. Okay. So if I ask you a simple question, try to answer this. Find average velocity in going from O to A by 2. So what is the average velocity definition? Total displacement upon total time A by 2, and time is how much? T by 12. So what is the answer? It is clear?
Yes.
Okay. So let's do some other formula derivation. So because it is performing SHM, let's say on a straight line between plus a and minus a, okay. So let's say let at x equals to x1 some displacement from the origin at x equals to x1. The speed is v1. At x equals to x2, speed is v2. Find a and omega. So which formula are you going to use? So which formula relates the v with x with position from the mean position?
V is
First,
equal to omega under root a square minus x square.
Very good. So now you know that we have two variables and we have two equations. Solve it. You look at the answer. Find the amplitude and omega. Do this.
So done.
Very good. Tell me the answer.
So A is equal to root under V2 square x1 square minus V1 square x2 square divided by V2 square minus V1 square.
है ना?
Yes. And omega is a V1 divided by root under x1 square minus x2 square.
How much? Omega is?
V1
Hmm?
divided by root under x1 square minus x2 square.
No, I don't think so. So V equals to A, sorry, omega. Okay, yeah, that's. No, I think V equals to omega under root of A minus. So V1 equals to omega equals to V1. Now A I have to substitute here. No? So after substituting, are you getting this answer? This is a big answer. So okay, I am getting this answer. V1 by V2 under root of V1 minus V2 square by x1 minus x2 square, right? This is the answer. So just rearrange properly, you will get the answer. Okay. Now, again, there's some simple mathematics you can see clearly from the formula itself. So we have again, we have equals to what is this? So what is the maximum value of acceleration? These are see, minus is just for direction, but if you're just finding the value, you can ignore the minus. And what is the maximum value of acceleration? What is A max? So as x will increase, A will increase, right? So when A will be maximum, when x is maximum, and we know that x cannot go beyond A, right? Do you realize this?
Yes, sir.
What is V max? What is V max? Tell me.
When A is minimum.
So you can see that there's a formula here. No? What is the maximum value of V when x is minimum, right? And what is the minimum value of x? 0.
Omega A.
Omega. So you can see that the velocity becomes maximum at mean position and acceleration becomes maximum at extreme position. Or you can say in this way that where the velocity is maximum, acceleration is minimum and vice versa. Because at extreme position, velocity is zero and acceleration is maximum. At mean position, velocity is maximum, but acceleration is zero. So you can always relate these two. And knowing the V max and A max again can give you the answer like A. So from these two equations, let me rewrite. If A max is omega square A and V max is omega into A, if you divide these two equations, what you can get? A max by V max is equal to how much?
Omega.
So if you know the A max and if you know the V max, you can find the omega. And if you want to find the amplitude, you can just square it. So V max square upon A max will give you what? Amplitude, isn't it? Just manipulation. Is this clear?
Yes, sir.
See, I'm trying to do every question mathematically before I go graphical method, because those are very easy method. And once you learn the easy method, you will never come back to this rigorous method. So first we'll do everything from mathematical point of view without understanding the easier methods, because you need to good with mathematics. Okay. So what else we can do? Now we can do a lot of things. So what I'll do is I'll give you graph, and I want you guys to convert that graph into a mathematical relationship. Okay. So interpretation. So now let's say a particle is performing SHM, a simple harmonic motion between the two extremes plus A, and the mean I have to connect the origin. So this will eliminate the effort of writing displacement and coordinate, both are same now. So what I found is that when I saw the particle for the first time, I saw the particle here at A by root. So it goes from here to here. Okay, that will be the next question. So if I t equals to 0, you were at this location and you were trying to move towards right, towards the extreme position, then at any instant of time t, what will be the x value? Think about it.
Sir, can you again repeat the question?
Yes, tell me.
Sir, can you again repeat the question?
Previous pages.
No, the question.
The question is simple, right? If you know that you start from t equals to 0 at a
Okay,
location a
then
by
x
2,
is
then
equal to a by root 2 bracket sine omega t plus cos omega t.
no, nothing like that. See, x will always have this format.
Sir, that only I will.
And what I am saying is that the only thing you need to do is find phi and substitute because the rest is okay.
Yes, that would be pi by 4.
So we all know that phi is defined as sine inverse initial position upon a. This is sine inverse 1 by root 2 if you substitute the value which is pi by 4.
So I did this.
The answer for x is a sine omega t plus pi by 4. That's it.
So, sir, I evaluated it further.
Hmm? Okay,
I
you
evaluated.
expanded it. Okay, no need to write like that. So we always write in the most compact form possible. Okay. So now this is okay. The big problem comes if I change the direction. So it means in the same problem, you say you begin at h equals to 0 at a position about root 2. But the difference is you were moving towards left. You know how to write down. So how to write down? So probably you will have no idea how to do this. But as of now, just remember one thing. If I want to convert this into angle, if we start from here, this is called 0 degree or 0 angle or 0 radian. Extreme portion is called pi by 2 radian angle. When you go from here to here, you go from 0 to pi by 2. When you return back, this is pi by 2 to pi. When you go from here to here, it is pi to 3 pi by 2. And we go from here to here, this is 3 pi by 2 to 2 pi. And this is the end of the journey. So in terms of angle, this is the journey how we traverse. If you are here, you know that this is how much angle wise pi by 4, correct? If you remember the derivation earlier, if this is pi by 4 and if I'm moving this way, so the whole angle from here to here is how much? What is this angle? Can you guess? So we know that the entire angle from here till here is phi. This is pi by 4. So what is the remaining part?
I minus 5
Pi minus pi by 4. Exactly. So
P pi by
the rule is when you reverse the direction, we have to subtract from the pi value. Understood? So this is what we do. So I'll give you some simple way. This is not a nice way to do the thing. So the only difference of the answer is x equals to a sine omega t plus pi minus pi of. This will be your answer. But anyway, we'll come to that how to get the answer in a nice form. So before we do all this problem, I would like to teach something called please shut down, switch off your microphone, whoever is
Sorry.
playing. So simple harmonic motion versus uniform circular motion, UCM. So SHM and UCM are correlated because of certain interesting mathematical reason. So if you look at the position and the time relation, you can see it's following the sine function. So such a function called sine is called sinusoidal function. And the property of sinusoidal function, if you remember, we can always convert into a circle. If we take the center of the circle as the origin, and if you choose some random point P on the circle, and if you join this circle with center, and if you take this angle as theta, if I call the coordinate of x and y, so from mathematics, what we know that the value of x is nothing but the, let's say this is the radius r cos theta, and the y is r sin theta. So the whole idea of circle or circular motion is that every sine function can be interpreted in terms of circle. So although you're moving on a like a straight path, but I can project your straight path onto a circular motion, which will have similar characteristics. But let's see how. So for that, I will take some demonstration. Let's say this is the wall, and this is the circle, and let me do this. Just Okay. So imagine there is a peg. I mean, the red dot is like a peg, maybe a nail, and we project a. Let me change the color of this. So what we do is we project light onto the wall. So now the peg which you're looking at, the red peg, where the shadow will you form right now? The shadow form will be here, right?
Sir, what is the red?
The red dot is like a nail, a peg.
Huh.
So the light is hitting the wall like this direction. So where the shadow you can see? Tell me, where is the shadow of this red dot
Sir, the
center, right? This is here. Now, once the peg will start moving in this circle with constant angular velocity omega. So after some time t, the peg will be somewhere here, right? Now, where is the shadow? Now you can see shadow is here. So shadow has come here. So you can see that as you travel this way till the extreme, shadow will travel.
Upward.
So can we go beyond this? No.
No, unless your object is bigger.
So in the first, so when you're moving in the first quadrant, you go from mean to extreme. And you can see that this is called amplitude. And if you correlate it, the radius of the circle is same as amplitude, isn't it? So do you realize the radius and amplitude relation?
yes.
In the next part of journey, you will start going back to the mean position. So once you move back, so when you are here and going back, basically you are in the second quadrant. Can you realize this? So in terms of circle, coming back is like second quadrant, going away is first quadrant. This is going away, coming back. So coming back is the second quadrant. Then you come back to the origin again here. At this instant, you're trying to go down. You're moving downwards. So then you go in the third quadrant. So in that case, you go in the third quadrant. So coming down, so from mean to the below value, the negative direction, let's call this as negative direction. Let's call this as positive direction. So going from the mean to the negative direction, so minus this is like minus a, it's like a plus a. So it is like moving in the third quadrant and then going back from the minus extreme to the mean is like going to the fourth quadrant. So when you complete one oscillation, you can look at the circle, you complete one circular motion, one complete circle, right? So we can in a way convert a system into one simple circular motion, uniform circular motion. So every system can be interpreted as uniform circular motion. And now try to understand what I'm trying to say here, more importantly. If I join the center to the particle's position, our motion is happening along this axis, and the horizontal line we call as the reference line. Here we don't have x and y axis, we have only one direction. So this angle is called phase angle. In a way, you can say that for every linear position you can project onto circle, you will get an angular position, and this is called phase angle, theta. And we write as theta as a phase angle, and the phase angle means the angle with respect to reference at any time t. It is quite possible that at t equals to 0 you may be here. If I assume that you are here, which means on the axis you are here, at t equals to 0, then this angle is called initial phase angle phi. This is called phi. And this angle you traveled in time t, this is called omega t, because you are moving with angular speed of omega. But omega in this context is called angular frequency, because there is no physical movement on a circle. It's just a mapping actually. So you're mapping the straight line motion onto a circle, and one oscillation is equivalent of one complete circle. So when we measure things on a circular scale, then the omega in this case we call angular frequency. We don't say angular velocity as we used to say earlier, but mathematically it is somewhat same. It does not mean it's an angular velocity, because our particle is moving on a straight line, not on a circular path. So theta is called phase angle, but phi is called initial phase angle. And initial phase angle is sometimes called or just initial phase. So there is a relationship between theta and phi. So theta we can write as phi plus omega t. Is this clear? Is this clear, guys?
Yes, sir.
So now you know what is a different symbolic meaning. And the benefit of a circular motion is that you can convert a SHM problem into a problem of circular motion, which is much easier to solve. So imagine again, let me complete this. If we have a circle, we take the horizontal as a reference line. We will take the vertical as the motion direction. Let's plot on the circle itself. Don't plot the screen separately. And imagine the particle is here at t equals to 0, which means you can project on the circle either right or left. Now, how to project it? Should we project right or left? Depends on the direction of motion. So if it is moving away, then which quadrant? So always remember, you move like this, and the actual particle is going away from the mean position.
First
So
quadrant.
we must project onto the first quadrant, because we know that in the first quadrant, if I project, then it is going away, right? But if you project wrongly on the second quadrant, then you can see the direction is downward, so it's a wrong assumption. So the arrow of the actual particle will tell you which quadrant to project, right or left. Is this clear? So now you know that I need to project on the first quadrant. So this is
So
value.
please will you repeat the arrow?
See, you're trying to go away from the mean position.
Yes, sir.
At t equals to 0, your direction is towards the extreme, isn't it?
Yes, sir.
Now for every linear portion, there are two possible projections, on the left part of circle, on the right part of circle. So which part to choose depends on direction. So if I choose the left part, the motion is towards the origin. Okay?
Yes, sir.
Understood. So you're trying to move towards the, if I project on the left quadrant, left circle, the particle is following the same direction. Can you see that? Yes or no? These are opposite, right?
Yes, sir.
So we cannot project on the left now. So where will we project this motion? Only on the right.
Yes, sir.
So by looking at this arrow, you can understand where to project. So now we know we have to project here, and this is the projection at t equals to 0. So this angle will be called phi.
5.
In any time t, you will travel only by omega t value.
Yes, sir.
So this angle is always omega t. And we all know that the radius is nothing but the length of the radius is nothing but the amplitude of oscillation. So what I am looking for is where I am now on the x-axis. So if I draw a perpendicular from here, this vertical length will give you x value, isn't it? So what we can add x value? X equals to a sine
Omega t.
omega, correct?
Yes.
So now you can get the answer directly by circle. No need to do any tough calculation. You can do multiple things just graphically. It's so easy. So imagine I want to know the velocity. So I want to know the velocity at any instant. See how easy I can do this. So imagine you are here moving away like this towards the positive direction. And what is this velocity in circular motion? So tangential velocity is how much?
Omega.
R. So V equals to omega R. Okay. Understood.
Yes.
So how to convert into the problem that we want? So we want the velocity in the direction of x-axis. So this is theta. So this will be how much? Theta only. Theta, theta. 90 minus theta, theta. Is this clear? So what is the
Sir,
x? Yeah,
so the vertical one is x-axis.
Omega a constant.
yeah, correct. What? So what we write is Vx. Basically, we don't write, but this is Vx. We are writing the x component. No? So what is Vx? V tangential cos theta, and that is equal to omega a cos theta. And again, if you remember, the cos theta is nothing but cos omega t plus phi, right? Hmm? Is this clear?
Yes, sir.
It's pretty easy, no? And let me derive the acceleration formula from circle itself. So in fact, you can derive anything you wish to using the circle.
So we have to just replace with omega square.
Yeah, so you have to just take the component along the parallel to x-axis. So let's say you are here. So let's say you are at angle theta. So we know in case of circular motion, the acceleration will be towards the center AC, and it will have component parallel to x-axis. So this component will be like this one. This is 90 minus theta. So what is AX? AC sine theta, and as you can see, the direction is negative. So it is not parallel to x-axis; it's anti-parallel, so minus. And what is the acceleration in case of circular motion? Omega square r, and theta is omega t plus phi. So you can see we can derive all formula from circle by taking the projection or component of velocity and acceleration. Is this clear? Maybe.
Sir, your 5 will be 0.
Pardon?
5 will be 0 now.
No, why 5 will be 0? I don't know whether it has started from the origin or somewhere else. I have no clue. So it may be possible that when t was 0, you were here, and now you are here. So your phi is this much, no?
Yes, understood.
See, phi equals to 0 is a special case, so that you take especially located. But this is how we do it. Okay. No. So now you can always calculate the time to go from anywhere to anywhere with circular projection easily. So how to do that? So let's go back to the same problem that I have been asking. You start from origin. This is the extreme position, positive, negative extreme position, and let's say you start from somewhere a by 2. You are moving towards right. You go here. You reach extreme. You come back. You go on the other side, and you end up reaching the a by root 2 on the left side. So if I say t equals to 0 here, and if I say this is t equals to t, can you tell me how much time you will take to make this entire journey? So now solving on a linear scale is a difficult job, but you see how easy it is to solve. No? So circle scale. So just draw the picture on a circle. So that will be a challenge for you in the very beginning, but that's okay. So once you overcome this barrier of converting this formula, I mean this motion into circle, it's a one-line answer. This is x less than x. This is the reference of this.
So we have to find time.
Yeah, time. How much time you will take to go from here to there? Can you do this, or you want to try? You can try. Now the answer is express your answer in terms of time period t. So I want t as a function of time, like fraction of t. What is a t multiplied by something? Okay. So you want to solve, or shall I solve further first? Tell me.
That's all.
Okay. Look at this. So first of all, you are at a by 2. So you have to mark a by 2 here, and you are going towards the extreme. So you're going upward. So which quadrant you start with, first or second?
First quadrant.
This is where you start with, right? So the rule is you join the center to the point. Can you find this angle? Yes, you can find. Because this is a by 2, so you know this answer.
5.
This is a by 2. This is a. This will be how much? 5. So sine phi is how much? 1 by 2. Phi is. So you know this is pi by 6. All right. Then you start the journey like this. You reach the extreme, and you come towards the mean, but you don't stop there. You go on the other side till you reach the minus a by root 2. Right? That's fine. And you're still going towards the left, so you're in the third quadrant, as you can understand, hopefully. Join this. Now just find the value of this angle because that is sufficient. Or maybe this angle. This angle. So this is a by root 2 numerically. This is a. This is alpha. So you can just write it. Again, what is sin alpha?
1
1
by
by
root
root
2.
So alpha is basically pi by 4. Right? So we know this angle is pi by 4. So if I look at your journey, then this happened from here to here. And if I call this angle as theta, then what is theta? That's easy to find out. So that will be pi by 2 minus pi by 6. That is this angle. Plus pi by 2, the next entire quadrant. And then alpha. Right? Okay, don't remember this. But I'm saying. So
Now
now only
alpha
job
will
is
be pi by 2.
yeah. So the pardon this angle, this angle. You are going from here to here. No? So how much is that angle? Pi by 2 minus
Oh,
5 plus pi by 2 plus pi plus alpha. Correct?
yes, sir.
Do you realize? Do you realize how much you have turned? That's it. And now you substitute the value of phi and alpha, which you have already calculated separately. Pi by 2 minus pi by 6 will be how much? Pi by 3, right? The LCM is 12. So 3 4 is 12, 2 6 is 12, 4 3 is 12 into 5. So we know theta equals to 13
13 by 12
pi
by.
by. That's good. Now, how to get the time answer in terms of time period? So we know that in circular motion, theta equals to omega t. Yes. So 13 pi by 12 is equals to omega, and how we write omega? 2 pi by capital T. Because I want answer in terms of time period. Once you write like this, your job is done. So T equals to 13 T by 20. This is the answer. Easy.
Yes, sir.
Now, can you tell me what is the average velocity of this journey? So, what is the average velocity of this journey? Tell me. Only magnitude. Tell me the only magnitude.
2 pi by 2.
Pardon?
2 pi by 2. Sir,
Sir, I got answer 4a into 2 plus root 2 in bracket divided by 26t root 2. 26t root 2. Yeah. Your voice is not audible.
I'm audible now.
Yes.
So if you go from plus a by 2 to minus a by root 2, what is your displacement? Just the
A
sum of
by
the
2 plus a by root. Yes.
and time, we got the answer already. So divide the displacement upon time, we get the average value. That's it. Understood. So is this your answer?
Yes, sir.
Okay, so after simplification, this will become this much for saying this. Huh?
Yes, sir.
Okay,
I did
fine.
the same thing.
Very good. So that's the right answer. So whenever you get a time question, like if you want to go from there to there, I mean, how to get the time. So this is the nice way. Convert into a question of circular motion and then get the time. So let's do the old problem that we did. How much time will it take to go from 0 to a by 2 and a by 2 to a and do it graphically, like using the circle. Just try this. It's not difficult. And see yourself whether the answer is matching or not.
Can you repeat the question again?
Find the time period to go from 0 to a by 2 and a by 2 to a using circular projection method.
Sir, got it.
So the answer is matching t by 12 and t by
Yes.
6.
Yes.
So you are able to get it using mapping of circle.
Yes.
Good. So anytime, any question which ask for the time. The only job is to plot on a circle, try to understand the beginning and the end, and rest will get the answer. So now there are various things that we can do uh, in terms of writing the initial phase. So there are some rules for writing the phi. So a person at t equals to 0 may be here, maybe here, maybe in the third quadrant, maybe in the fourth quadrant. So anything is possible. So which simply means you may be here, you may be here, you may be here. So I'm taking all possible cases. So let's say a person is here going towards up. So it's a first quadrant. You may be here but going towards down. So it's second quadrant. You may be here going towards down, third quadrant, and if you're here and going up, fourth quadrant. So the arrow will tell you the quadrants, right? Let's take all angle as alpha 1, alpha 2, alpha 3, alpha 4. So how to write phi 1, phi 2, phi 3, phi 4? So what is phi 1? So we always take the phi from the reference, right? And you can see the phi 1 is same as alpha 1. There is no difference. But what about alpha 2? I mean phi 2. Phi 2 we have to take this angle from the reference. Do you realize this? And so it becomes pi minus alpha 2. Okay. Now what about the alpha 3? So alpha 3 is even bigger angle. But if you take the angle like this, the problem is it exceeds the 180 degree. In vector we have studied it, we always write the angle from minus pi to plus pi. So we make sure that we maintain the angle phi from here to here only. And therefore, if something exceeds the pi value, we go on a reverse direction. So this angle is how much? It is pi minus alpha 3, right? But with negative sign.
There are negative sign.
Yes. And what about the alpha 4, the pi 4? Again, it's the same thing. It is alpha 4 with negative sign. It is clear?
Yes, sir.
Yes.
And therefore, it's very easy to write the equation. So if you start in the first scenario, the x will be written as a sine omega t plus alpha 1. In case 2, the x will be a sine omega t plus pi minus alpha t. Here the answer will be a sine omega t minus pi minus alpha 3. A sine omega t minus alpha. This is how we write the x value once I know the phi value of every possible journey. So I have taken all the 4 cases, but there are some interesting cases which you will encounter very often. That's called the extreme journey. Either you start from the origin or extreme position. So that is something which we can just do it by common sense, but still let's do it mathematically. So I want to take the T0 exactly at origin. Like you were here, and then I assume that this is T0, but you are moving towards right. This is the best case scenario. The x will be a sine omega t. Correct? Easy.
Yes, sir.
So this is the case of zero angle, the zero phase angle. If you plot on a circle, you won't see any angle. But in the same case, if I make a small change, and if I call this as plus a, this is plus a. So I have changed the direction. At the very beginning, you were going towards left. So you started moving in which quadrant? Directly in the fourth quadrant, isn't it? Going from mean to extreme, which quadrant?
Yes. Fourth one.
Fourth quadrant. So you're going from mean to extreme. Basically, you're going from like this, you're moving this way. So if you start moving this way, then the way to write is instead of traveling towards plus direction, you're traveling towards the minus direction. So the answer will change only a bit. Minus. That's it. Okay. This will become minus a sin omega. This is how we have to write. And the other two scenarios. So let's say you start from the plus extreme and you start going towards this. How to write the equation here? So you are here actually, and you're trying to go down. Which quadrant? Second quadrant, right? So when you are here, what is your angle?
Pi by 2.
Pi by 2. So when you write x equals to a sine omega t plus pi by 2, what will happen? It becomes cos function, right? And that is common sense. When t is 0, x is maximum, only cos 0 is 1, right? So when you start from the extreme position, it must be cos function. Do you realize this? Because only the cos 0 is 1, isn't it? Are you getting the answer? Like what I'm saying?
Yes.
So the moment you start from the extreme position, it is bound to be cos function. So if you start from the minus a, so definitely you will go towards right. The only difference is it will be negative answer, minus. So these four examples are very, very unique, and just remember the answer. So the best answer you can remember is this and this. So let's say with these two answers, I can solve any question. I need not to go through all those things. Like so, let's say someone is asking me to solve this question. Like I just choose some random value, let's say some a small a value. How much time it will take? So let's say I'm trying to ask you how much time it will take to go from here to there. Now this is the question that I okay. You start from the extreme position. You want to go to the A. How much time it will take? Now, if you try to apply various formula, you may get confused. The best way is don't calculate anything. Just look at where you want to reach. Look at the origin and think of how much time you could have taken to go from here to here. If I can find the t value, rest I can anyway find. So what is the t value? It's simple. I want to know how much time it will take to go from origin to somewhere. So which formula I will take? A sin omega t. I will just choose this formula. Why? Because this is the formula which tells you that if a particle begins at origin and going towards the positive extreme, then every instant the x will be governed by this formula. Now that's an interesting one. And I want to go to A. This is A. I got the t. T is how much? 1 by omega sine inverse A by A. Although it looks weird to write, but this is the right answer, right? But the question is not this. They're asking what? They're asking how much time it will take to go from here to here. And what we know that for every quadrant, the total time is how much? T by 4. So the answer which they are asking, so let's call it delta t. So what they are asking? Delta t. So can we say t plus delta t must equal to t by 4? So the answer which they are asking, we can rewrite as t by 4 minus, that's easy, right?
So why t plus delta t?
So in SHM, every quadrant will take how much time? 1/4 of the
T
total
by
time.
yes, sir.
So if I know this answer, then the remaining answer must be how much? The difference of the two. No? See, whether you go
Okay.
right or left, the time remains same. It's a symmetrical oscillation. So if you take time delta t to go from A to capital A, to come from capital to A will be same, no difference.
Yes, sir.
Is this clear?
Yes, sir.
So let's say if I give you this question, and you can avoid everything and just solve in one line. So let's say I'm giving a question like uh, so maybe I can ask you a question like how much time it will take to go from maybe here to somewhere here, like this. How much time will it? So don't try to solve all questions. Just think the way I said. Think of how much time it will take to go from here to here, and how much time it will take to go from here to here. And don't try to take a value or sign value. Just take a numerical value because the time is. So whether you calculate on the left side or you calculate on the right side by same value, it's the same answer about the origin. So if I know this answer somehow, if I know this answer somehow, I can solve for the rest, isn't it? So finding T1 is pretty easy. What we can write x a sine omega t because I am always taking the origin to somewhere formula, nothing else. So I want to go to a1 distance away from origin. This is a sine omega t. See, in fact, for the left side for t2, don't write minus n all. You simply take a2 equals to a sine omega t, and it's the same thing. Why it is same thing? Because if you try to go from here to here, the formula will become the negative one, this one. So if you equate with minus a2, you will get the same answer. Minus cancels out. Do you realize this? What I'm saying?
Yes, sir.
So it's good just to take the value. Don't take the sign and all. So the numerically I got t1, which is pretty easy to write, which is 1 by omega sine inverse a1 by capital A, and the at2 will be 1 by omega sine inverse a2 by capital A. So I know the t1, t2. So rest I will manipulate. What I will manipulate? So I know this time is how much? T by
T by
4
4
minus.
minus T1.
Now this entire time we know is T by 4, and this time we know T2. Correct? So I got the answer. So the total time of journey is how much? T by 4 minus T1 plus T by 4 plus G2. That's it, isn't it? So this becomes T by 2 minus T1 plus T. So even a most complex question, if I just want to know from where to where I want to go, yeah, I mean, what I'll do is I will not calculate the other point value. What I'll do is I will simply calculate the origin to that point, and I will do the manipulation to get the other answer. So do you realize the method? What I'm trying to explain here? This is the most challenging problem you will come across. Is this clear? Hello, hello, 1, 2, 3. Am I audible, guys?
Yes,
Yes,
sir, I'm
understood.
Okay, so this was the most challenging part of this chapter. Rest will be very easy. So we have graph, mathematics, I mean some energy relation. But even with this much knowledge, you can do some problem. Very few actually, to be honest. So I need one more lecture to actually give you the big picture of SHM problem. So till then, I'll share the main sheet. Just a moment, let me share it right away.
Sure.
Yes, tell me. Hello, hello.
Sir, in page number 18.
Am I audible?
Yes, sir.
Yeah, tell me. You were saying something.
Yes, sir. So in page number 18, that minus a sine omega t one example. Uh, in that, why it is like starting in, if we compare circular motion graph, what is starting from the fourth quadrant?
So you're going towards down, no? So you have already moved it. So it's like you moved pi value. Then you're going down. Understood? You're going from here to here. So you're actually here and you're going down. So you have already traveled pi value. So if you add a sine omega t plus pi, you get minus like this.
Yes, sir.
You can derive.
Understood.
You can derive that. Okay, so I have shared the sheet now. So you can solve the exercise one, section A. And you can also solve the exercise one part two, section A. So these two things you can solve.
Sir, please will you repeat?
Oh, I have it in here. So go to the exercise and solve this part one, part two, exercise one, part two, section A. That is what we can cover when from this knowledge. All right. So rest we'll see in the next lecture.